we're talking about matter, people. We're talking about matter. We just did our exercise to warm up, and now we're going to see why matter matters. You guys get it? Wonderful. Now, as I'm taking notes right now, you should not feel like you have to write down every word I have written down, okay? Do not write down every word I have written down. That'd be way too much work. But just kind of focus on the highlights, okay? Kind of focus on the highlights. So, matter is anything that has mass and takes up volume. So, matter, mass and volume. So, mass and volume. If it's got mass and volume, it's matter, and guess what? Everything is made out of matter. Matter is everything, okay? Uzama's made out of matter, so is the pencil she's writing with, so is the paper she's writing on the pencil, writing on with the pencil, so is the table that her paper is sitting on, so is the chair that she's sitting on, so is the floor that her chair is sitting on, that she's sitting on. Everything is made out of matter. I just breathed in a bunch of oxygen. That's a bunch of matter because oxygen has mass and it takes up space, has volume. Everything's matter. Everything's matter. Got a little lightheaded because of my mass. Whew. Holy crap. So hot. Okay. Now there are 4 different flavors of matter. Okay. 4 flavors, and they're in 2 categories. So pure substances contain the first 2 types of matter. Pure substances contain the first 2 types of matter. What is a pure substance? It's a constant composition with fixed ratios of elements. Mr. Pilcher, that sounds like some odd wording. I'm not sure if I fully understand that. That is okay. I will be explaining what I mean by fixed ratio of elements here shortly. But just so you know, it has a fixed ratio of elements. It cannot be separated by physical means. So if something is a pure substance, you can't separate it by physical means. Again, we will go into this a lot further. All right. So now we're going to get to our first 2 types of matter. So again, the first 2 types are pure substances. Type number 1, elements and elements. Those are substances that cannot be separated into simpler substances. Okay? Can't be separated into simpler substances. They are the building blocks of everything around you. Again, you should not feel like you have to write down every single word here. Okay? So examples are chlorine, sulfur, anything on the periodic table. Gold, silver, platinum, oxygen, nitrogen, hydrogen, helium. Those are all elements. Here I have a couple examples. So this is an element. This is pure zinc. This, I got some pure copper. I cut these and almost cut my little finger off over the weekend, but here we go. So these are pure substances right there. They are elements. And this box right here is an example of a pure substance, which is an element. You see how every single little atom in here is exactly the same. They're all gray circles. Okay, that's saying I have an element, where everything in there is exactly the same. Okay, so matter type number 1 is an element, and it's also a pure substance. Matter type number 2 is a compound. Compound. Okay, a compound is 2 or more elements that are chemically joined. So that's when you have more than one element and it's stuck to each other. More than one element and they're stuck to each other. And when atoms join, they lose their individual properties and gain new properties. I'll explain this in a second. But individual atoms are very different from compounds. All right. I know I'm going pretty fast. So I'll chill out here for a second. Woo! Stretch those fingers. Monday, man. Oh, and you guys are about to go to lunch after this. Goodness gracious. All right. So let me explain a little bit more what I mean. Okay. So here are a couple examples of compounds. You do not have to write this down. So NaCl, those are sodium stuck to chlorines. Yes, Uzama?
Can you repeat what compounds is again?
A compound, it's 2 or more elements that are chemically joined. So when you have at least 2 elements and they're stuck to each other, they're chemically joined. And one example is sodium, sodium chloride, NaCl. So that's a sodium element stuck to a chlorine element. This is NaCl right here. Okay, salt. That's it. Salt right there. Go right here. We have a large gray circle stuck to two white circles. That's actually what H2O looks like. So here's some distilled H2O. Okay, this is a pure compound, it's a pure substance, and it's a compound. There's nothing but H2Os in here. Or C6H12O6 can be a whole bunch of elements stuck to each other. Does anyone know what that is? Glucose, that we're going to say too. Yep. Sugar. Yep, this is sugar right here. So, when it says lose their individual properties and gain new properties, let me explain what I mean by that. And again, you don't have to write this down, it's just an example. So if I take some pure sodium and put it in water, it's like a bomb. It will explode very violently. We have some sodium locked behind a door, locked in a cabinet. Okay, it's very dangerous. We keep it stuck in mineral oil. Chlorine gas, that's a toxic gas called mustard gas. You can use it to kill people in warfare. So this kills you, that kills you, but when you have them together, this will kill you if you don't have salt in your system. Kind of interesting. So the individuals by themselves, so sodium by itself and chlorine by itself, are completely different from each other, and they're completely different from NaCl, which is what they are when they bond. Okay? So when I say that individual atoms will lose their individual properties and gain new properties, that's what I mean. Shiny explosive metal, yellow gas, kind of chalky white powder. Okay? Or crystals, really. All right, let's talk about pulling things out of the hat. So pure substances. This is a good visual for you guys. I think this really helps clarify things for folks. So our first two types of matter are pure substances. And here's what I say. So this is not, you're not going to find this in a textbook, but this is what Mr. Pilcher says. They're always going to pull the same thing out of the box. So pure substances, you're always going to pull the same thing out of the box. So let me show you what I mean. These are our three boxes from the beginning of class. Okay? So we have G, C, and A. So, if I go to G, if I try and pull something out of G here, watch what happens. Every time I pull something out of here, oh, the G flies off. Red circle, red circle, red circle, red circle. Do you guys see how no matter what, if I pull something out of that box, it's going to be a red circle? So that's why this is a pure substance. Now, are all of these atoms exactly the same? Are they all red circles? Every single thing in there? Yes. So that's why this is an element. Over here, let's see what I pull out of the box. So I pull this, I get a red circle and a white triangle, red circle, white triangle, red circle, white triangle. What if I grab it by the triangle? I get a red circle and a white triangle. What if I grab it by the circle? I get a red circle and a white triangle. Do you see how no matter what I grab out of box C, I'll always get the exact same thing? So that's why box C is a pure substance. But because you have two different atoms, red circles and white triangles, that's why it's a compound and not an element. So you see the difference between these two? Over here in box A, though, I got a white triangle, white triangle, red circle, oh, white triangle, red circle, red circle, red circle. Oh, or the whole box. Oh, goodness. Oh, goodness. Come here. Come here. Here we go. Ooh. Okay, so you see how you don't always get the same thing out of the box every time? That's how you know we have a new type. That's a mixture, and that's what we're about to talk about next. So always picture what's in the box, and if you grab some out of the box, is it the same every time? If so, it's a pure substance, and then you just have to figure out if it's an element or compound. If you don't always get the same thing out of the box every time, it's going to be a mixture of some kind. All right. Let's talk about mixtures. Let's talk about mixtures. All right. So a mixture is when you have two or more substances and they're mixed together. Two or more substances mixed but not chemically joined. Okay? So you have two or more substances, they're mixed, but they're not chemically joined to each other. Not chemically joined to each other. The substances retain their individual properties. Retain their individual properties. Okay. So, The first two types of matter are elements and compounds, which are both pure substances. Here's type number 3. A homogeneous. Homo means same. Genius means look. So a homogeneous mixture has the same look, or some people would say it looks the same throughout. So mixtures that look the same throughout. Or you could say they have completely even distribution. Everything is distributed evenly. So for example, in this picture, okay, we have clusters of 3 white circles. They're spread pretty evenly throughout. So like this section up here has like a couple of them. Up here we have a couple. Down here we got a couple. Over here we have a couple. They're sort of spread evenly throughout. So we could pull out 3 white circles. We could pull out 1 gray circle. So that's how we know we have a mixture. But they're evenly spread. Evenly spread. And then the fourth type is a heterogeneous. Hey, Grace, if homo means same, what do you think hetero means? Different, yeah. Different look. So this is where the mixture will look different throughout. Mixtures in which you can see more than one type of matter. They can have more than one type in the mixture. So maybe something like this. So this guy right here, we have giant clusters of white circles. There's like 5 of them down here. There's only a couple on the top. Okay? Or here, these are all white circles below this line and all gray circles above that line, where there's 2 things in there, but they're not mixed evenly. Okay? So some real world examples of these 2 kinds of mixtures. So here's some tap water. Tap water, is this pure H2O, like distilled H2O? No. When I get water out of the tap, is the only thing I'm getting here H2O that came out of the tap right there? Can someone tell me something else that's in the tap water? What's that? A little bit of chlorine, a little bit of fluorine's in there for sure. There's a lot of different minerals, okay? A little bit of iron's in there. So this is a homogeneous mixture because every sip tastes the same. There's not just H2O in there. Or here I have some copper sulfate. So we have copper sulfate in there, but it's mixed with water. So the whole thing looks the same throughout, but it's not a pure substance either. And lastly, I have some blue water mixed with some vegetable oil. Looks like this. See how it's blue all on the bottom, vegetable oil on top. This is a heterogeneous mixture, okay, because there's 2 things mixed, but they're not evenly. If I were to go like this, okay, now it's homogeneous because they're mixed evenly. Now, these 2 will separate over time. So if I set this right here before you guys leave, it'll look just like it did about 30 seconds ago. So homogeneous right now, but it will become heterogeneous as the 2 separate. Hey, oil was on top. That means it was what? Less dense. There we go. Nice. Okay. Let's go back to some of those original mixtures. Mr. P would say it's possible to pull different things out of the box. Possible to pull different things out of the box. Okay? So let's say Aurora Bell goes to box A. She's like, oh, she grabs the whole box. And she's so strong. She grabs a triangle, and then a circle, and then a circle, and then a circle, and then a triangle. So she can pull more than one thing out of the box. So that's how we know this is a mixture. Aurora, were those mixed evenly or unevenly? So what kind of mixture is this? There you go. Love it. Homogeneous, because it kind of looks the same throughout. I don't know why that happened. Stop it. Stop it. Okay. H over here. So let's see here. Mr. Craigwell, if I grab some out of here, will it be the same every time, or could it be different? It could be different. It's possible that would be different. 3 circles, circle and a square, 3, not the same every time. Okay? Now here's the question. Are they mixed evenly, or does it look different throughout the substance?
It looks different.
Right, yep, because you have circles and squares on the bottom, clusters of circles on top. So this would be a heterogeneous mixture. Alrighty. So let's see here. Hey, McWigan, can you see my screen okay? McWigan? Maybe? There we go. Hey, can you tell me, what would you call D? Is D, will I get the same thing out of the box every time? I will. So does that make it a pure substance or a mixture? Pure, yep. So every time I grab some out of here, I get a square and a circle, square and a circle. Now, would you say this is a compound or an element? Yep, because why?
It's the same for that. And two elements are joined together.
Yep, we have circles and squares joined together, so this is a compound. So if we go back to the first thing we did that made everyone super confused, let's see if we can identify these groupings now. Okay? Hey, Jack, what would you call these guys over here?
Homozygous.
Oh,
Mixed evenly.
yeah, homogeneous. Yep.
Yeah, it's mixed. Both
Yeah.
A's mixed evenly. That's not.
Well, I mean, it's kind of mixed evenly.
It's not completely.
Yeah, it's not. It'll never be 100% perfect, but generally speaking, it's pretty even. So these are homogeneous mixtures. You guys see that? You won't always get the same thing out of the box, so you know it's a mixture, but they're spread evenly, so it's a homogeneous mixture. Uzama, what about E and H? What do you think these guys are now? Mm-hmm. Yeah. So how do you know they're a mixture? Mm-hmm. Yeah. Okay, so this is actually elements because it's all the same atom, but these guys are compounds because there's two different atoms. So if you pull some out of E, you won't always get the same thing, but they're not mixed evenly. So you know it's a mixture, but it's not even, heterogeneous. Grace, what would you call B and G?
That would be a pure substance,
Mm-hmm, for sure.
and they're elements.
Right. So B and G are both pure substances and they're both elements. B has only white triangles in it. So even though the white triangles are in pairs of two, there's still an element, a pure element, because there's nothing but triangles in there. This is actually what oxygen gas looks like. All oxygens are two oxygens stuck to each other. And here we have a compound because, again, it's a pure substance. No matter what I pull out of this box, it'll go square and a circle every time, but it's two different atoms joined to each other. Does this make a lot more sense than I did at the beginning of the period? Not bad, right? Okay, so where that leaves us, okay, so we're going to try this worksheet out. Now, virtual people and my live people, if you want to go ahead and take your 3-lecture question quiz right now, or 3-question lecture quiz right now, you can. It's in the Monday folder. And then after you do that, go ahead and knock out some of this practice. I will post the answer key to this first worksheet. So it's the first worksheet on this packet right here. I'll post that answer key in the Monday folder after school today. You live folks, I'll bring answer keys around to you if you want them. Okay? So if you want to take your 3-question quiz right now, you can. If you want to practice first and then take that quiz, you can.